Hey everyone, thanks for coming. My name is Don Coleman. I work for Chariot Solutions, and I'm going to be talking to you today about creating Bluetooth low energy applications. And so there's a lot of material to cover in Bluetooth low energy. So my goal here is to give you a good overall understanding, show you some of how it's used, and get you enough information to kind of be dangerous and start writing code. One of the things you'll see is that a lot of the code we look at will be done with Apache Cordova. We'll be writing things in JavaScript. But a lot of these principles will apply if you're writing native iOS, native Android, or if you're doing other things like writing with Node.js on the desktop. So the concept should apply across all these things. And we're just going to use Cordova as the implementation today for most of the things. So we're going to start off with Bluetooth, and Bluetooth was originally designed as a wire replacement protocol. So you could basically have two devices that would normally be connected, and now we can do this wirelessly. It runs on 2.4 gigahertz spectrum. It's been around for a long time. Bluetooth low energy is relatively newer. It started off with Bluetooth Classic, and that's the things, you get your Bluetooth mouse or speakers that you can run from your phone or things like that. And that works really well for a lot of things, particularly when you need to send a lot of data across. Bluetooth Low Energy has a lot of the same goals, where we want to connect two different devices and we want to send data between them, but as the name implies, it wants to use a lot lower energy. Theoretically, we're going to be able to make devices that run on a small coin cell battery for 2 years. In reality, you can't always get that, but you can definitely run small, low-powered devices. So we're going to do some marketing terms here first. There's Bluetooth. It's kind of the general overall. Bluetooth Classic, it's what if you get in your car and you happen to have a car that supports, pairing your phones, you can use Bluetooth Classic. Bluetooth Low Energy is a newer thing. It started off as a separate product and was kind of incorporated into the Bluetooth spec. I call that Bluetooth Low Energy. I think the preferred marketing term for that now is Bluetooth Smart. They keep changing these things. And then they have another name called Bluetooth Smart Ready, which I find even more confusing. And that means that it can do Bluetooth Smart and Bluetooth Classic. So your phone would probably be Bluetooth Smart Ready because it can do either Classic or Low Energy, whereas a lot of these devices we're going to be looking at, like a Fitbit or something like that, are Bluetooth Smart since they only do the low energy part. So if we look at kind of Bluetooth in general, there's this big stack, and this is more to illustrate where we're going to be talking about in the realm rather than worrying about the details. We're going to be more near the top of this diagram. We're going to be talking about applications. We're going to be talking about GAP, which is the way that devices find, discover, and connect to each other. And then the next layer down, the GAT and AT, the generic attribute profile and attribute protocol. Those two things were originally one concept. They've been broken apart for the spec, so it confuses things a little bit. But that's kind of how the devices, once they're connected, are exchanging data back and forth. And you'll find that once we break that down, the mechanics underlying that are very simple, and then you can build more complex things on top of that. Then as you go farther down, we're not going to talk about anything down at the bottom of the diagram. The farther down you go, the closer to the hardware you get, and there's a lot of cool things happening there. Not enough time for that today. So since we're going to be talking about writing applications, we need kind of this thing that we're going to connect to. So let's imagine that we want to have a light bulb that I can control from my phone. In order to do that, the light bulb is going to be what's called a peripheral, and it's going to provide a service. So we'll need to make a light bulb service. And the things that this light bulb will let me do, let me turn it on, turn it off, maybe dim it so I can get things a little bit nicer, and maybe it could track how much power it uses and then tell me, hey, you've used this many watt hours or whatever. So one of the steps in defining a service is we're going to assign UUIDs to stuff. Everything in Bluetooth Low Energy uses UUIDs. You're going to see them everywhere. So we'll start off, we'll give the service a UUID, FF10, and then we have these things called characteristics. Each of those properties that we talked about that we can set or read a value on, those each get their own UUID also. And this basically just gives us a way in code that we can refer to those things and say, hey, I want the switch, so I'll get FF11. We were using 16-bit UUIDs there. Normally, UUIDs are 128 bits. 16-bit UUIDs fit on slides a lot better, and they're a lot easier to hold in your head. So you'll see they can get expanded out into a 128-bit form there. If normally when you're creating your own services, you have to use 128-bit UUIDs. You just use a tool like UUID Gen, it spits out a new one, you can use that. For Bluetooth services that are blessed by the special interest group, they can get these short 16-bit UUIDs. So if you're creating a product, you want to get a short UUID, you can apply and go through a whole process to get these short UUIDs. So we're going to expand our service a little bit here. So services have things called properties, and that's going to be, can we read it? Can we write it? It has an attribute value. So when the light switch is on, the value will be 1. When the light switch is off, the value will be 0. And similarly, with the dimmer, we can set a value for the dimmer, or we can read what that was previously set to. And then some things don't make sense to be able to write. Like the power consumed, we shouldn't be able to set that from our phone because it's a calculated value. So that'll be read only. There's a couple other things. There's also permissions. And the permissions in this case are going to look exactly like the properties. Permissions can also have things like it needs to be write encrypted or read encrypted. So basically a higher level of security. For what we're doing now, we're going to just keep things at the very low level. And there's also something called descriptors. So a descriptor can be something like a human readable string, like the characteristic light switch. We could store that in a descriptor so that a tool that was introspecting could get that value. There's also things when we're going to do notifications that use descriptors. You don't have to worry about them too much, just kind of know that they're there. So we have services. We had that light bulb service. A service is built up of characteristics. Each characteristic has properties, it has an attribute value, it has permissions, and it has descriptors. So those are kind of the building blocks for what our service looks like and things that allow us to interact with it. So now that we have this service, we need a way to connect to it. With Bluetooth Classic, we would do something where we would go through a pairing process where it'd say, hey, scan for a device, pair, put in a PIN code, stuff like that. For the most part with Bluetooth Low Energy, you're doing something where the security is called just works. So you do a scan to discover devices, and when you get the devices back, you can connect to them and start working with them. Sometimes you'll get to a characteristic that has an elevated permission on it, and then it will go through what kind of resembles that previous pairing process where you'll need to do something like put a PIN code in to kind of elevate that level of security. But for the most part, when you get started, you can just start connecting and make these things work. In order to find a device, though, we have our light bulb sitting there, and I need to get my phone connected to it. The light bulb will sit there and it will advertise. And what the advertising does is every second or every 1/10 of a second or every 5 seconds, it will sit there and it'll broadcast out this little packet. And in that packet, it'll have things like a unique identifier for the device. That's different than the UUID for the service. It'll have a list of services that it supports. So it could say, hey, I support the light bulb service, I support the generic device information service, these other things. And it could potentially have a name like, hey, this is the living room light bulb or something like that. If you're working on Android, instead of seeing a UUID up there, you'll actually see the MAC address or the hardware address of the radio in there. When you're working with iOS, iOS gets in the way of a lot of these things, and they basically substitute the MAC address and keep that hidden internally and give you a UUID. So if I scan for a light bulb, I'll see one UUID, and if one of you guys scan for that same light bulb on a different iPhone, you'll see a different UUID for that device. The UUID is pretty consistent for the life of my phone. I should get that same UUID back, but it makes it a little tougher to track devices when you're on iOS. Android, you get a lot closer to the metal and you can actually get the MAC address. So if we look at the actual advertising packet, we'll get some MAC address, we'll get that list of services, we get something called manufacturer data, and on Android this is just going to be a binary array of a bunch of data, and there's a whole bunch of rules for decoding that. We'll look at that a little bit later. Then there's properties. Can we connect to this? Can we connect to this? Some devices you can connect to, some you can't. It'll give a transmit power level and the RSSI, or relative signal strength indicator. The combination of those two, the power level and the RSSI, you can kind of guess how far away you are from a device. It's not always that exact, especially with battery-powered devices where signals are fluctuating and stuff. But you can use that to guess, hey, is this the light bulb next to me, or is this the light bulb in the room over there? And then on here, we get a name, a smart light bulb. On iOS, we'll see this almost exactly the same, but instead of the MAC address up top, we'll just get some random UUID. The manufacturer data is a little bit different on iOS also. Instead of just being the raw array of bytes, they pull that into a map, and they only give you access to some of the data, and they hide a lot of the other useful data. So I find that incredibly frustrating. So now that the device is sitting there, the light bulb is advertising and saying, hey, I'm here. On the phone side, the phone is going to go out and what's going to call scan and discover peripherals. So the advertising can be relatively low battery usage. Basically, the processor wakes up, it sends out the message, and it goes back to sleep. And the hardware engineers have tuned that to be really efficient. On the iPhone side or the Android side, it's going to be our job to be more battery efficient. We could be scanning all the time for everything, and the users are going to hate our app because we're going to drain the battery almost immediately. So what we'll do is we'll scan for devices at the right time, and once we find a device, we'll want to connect to it. So we get a list of devices. Maybe if I'm scanning in this room, I'm going to see a lot of devices, people with Fitbits and other things like that. We'll say, hey, I see that light bulb. I know because it has a service, FF10, and I filter that, and I want to connect it. So in this role, this is a gap role. The phone is called the central, and the light bulb is called the peripheral. So the one thing we can do there is once we discover a device, we can connect to it. And they do some low-level stuff that's in the part of the diagram we're not talking about, and then we get a success. Hey, we've connected. Once you connect to a device, the usual process you follow is we get a list of services, ask it, hey, what can you do? Because there was an advertised list of services, but there's limited advertising space. So there may be 3 services advertised, and it may offer 15 services. And then for each service, we can go through that and say, hey, what characteristics you got? Each characteristic, what are the properties? Can we read it? Can we write it? If it's a characteristic we care about, we can save a handle to that so we can write to it later or read from it later. And we could potentially subscribe to be notified when something changes. And so we'll go through each of those steps a little bit more. But you'll see this pattern over and over again if you're writing Bluetooth Low Energy apps. So now here's where we get into attribute protocol. And this is basically just the way that once the devices are connected, we can exchange information. And so these are going to be client-initiated actions. And you'll notice the names have changed. As we went from GAP to attribute protocol, it becomes client and server. So now in this case, the client is the phone, and the server is the light bulb. And at first, it may be a little weird, like, hey, the server is the lower powered little tiny thing. But in this case, you think about it, the server has the information that we want. We're going to be querying it and asking it for things. So from that perspective, the client-server names kind of make sense. So we can read a value. We can say, what's the value of the light switch, the FF11? What's the value? And then the server will send back, hey, it's 1, it's on. We can also do something where we can write a value. So if the light switch is on, we can say, hey, we want to turn that off. So we write 0 to that. And the server sends back, okay, we shut that off. There's another kind of write called write command. And this is, a lot of times in APIs, this is called write without response. And basically, we just say, turn the light on, turn the light off, do whatever. And we hope that the light bulb does the right thing. We never get any response back. And for a lot of cases, this can work out okay. And the properties on the device will tell you if it supports write command or just write. And the nice thing about a write command is that the server is free to ignore the data that's sent in. So if it gets flooded with too many messages, it can ignore these write commands. So it depends on what you're doing, whether that makes sense or not. So I want to introduce another service now. And this service is going to describe kind of how we can get server-initiated data back to us. So the heart rate service is what a lot of these heart rate monitors use. This is one of those official services that's ratified by the Bluetooth Special Interest Group. And this has one characteristic on it we're going to care about, the heart rate measurement. We got a UUID, and its property is called notify. So the way notify works is if something's called notify, we can say we want to subscribe to that, and then anytime that property changes, the device will reach out and tell the client, hey, this property changed. So you don't have to poll, it's going to reach out and tell you, which is nice because that helps you use less battery. So notification works very similar to write without response. The server sends that to the client, and the client is free to ignore it, but most of the time it can read that and see what happens. There's also another kind of server-based notification called an indication, and this is a reliable, so the server sends the indication and says, hey, this changed. The client has to send back, okay, I got it. Until the server gets back the, okay, I got it, it's not going to send any more data. Something like the blood pressure monitors use this. So if someone has a blood pressure cuff and it goes, and once it gets that reading, it sends an indication to let the other app know what happens. Most things I've seen use notifications. From the writing code perspective, a notification and indication work very similar for us. At the iOS and the Android level, they're pretty much handled the same because the operating system is responsible for sending that confirmation back. As an app developer, you don't need to do that. So that was kind of a lot of information, but the takeaway from that I'd like you to remember is we have peripherals that provide services. So these are the smaller devices. And then we have the central, which discovers advertising peripherals, gets an identifier so we can connect to it. Once we connect, we explore the services and characteristics. We can read and write characteristics, and we can subscribe to be notified when something changes. Those are kind of the building blocks for how we're going to build this application, these applications. So if we think back, we're going to talk about the light bulb service again. So we got the switch, the dimmer setting, the power consumption. We want to write an app that's going to let us turn this light bulb on and off. Fortunately, there is a light bulb that supports that service. I have one right here, so we can use that. It's going to be really bright, Brian. So this is a light bulb I bought at Micro Center, and it was crazily overpriced compared to a regular light bulb. But you know, it does the job, and it has this nice Bluetooth service. Hang on, no, I did not. This is a duct tape kludge here. I'll hold that down. There we go. So one of the nice things about Bluetooth Low Energy is that we can write specific clients to do these things, but there's also a lot of generic clients that let us go out there and figure out what a device offers for services. Sometimes a manufacturer will say, hey, these are the services it offers. More than likely, they'll say, pound sand, we're not going to tell you anything about our device, download our app. But we can use, there's some tools, Light Blue is one of them. Let's see if I can do some screen sharing here. And it lets you go out and scan for devices, discover what's out there, and then we can kind of explore and see what is available, and we can reverse engineer a lot of services that way. So I'm just mirroring this iPod here so you guys can see what's going on. And we're going to connect to this RoboSmart device. One of the challenging things about doing presentations like this is there's sometimes a lot more Bluetooth low energy traffic than I'm used to. But we successfully connected. And as we scroll through here, there's all kinds of services. And here's this FF10 service we're using. So I can click on the light switch, and it reads the value. So you see that 01 there, that the light switch is on. So if we write a new value, we'll write 1 byte for off. We can turn that off. Or we can write a new value. We can write a 1, and we can turn that back on. And this is the same process that the app that comes with the device uses. I'm just using a generic app. This one's called Light Blue from Punch Through Design on iOS. I like it. It's really pretty good. There's a similar app called NRF Master Control Panel for Android, which is a little bit more full-featured on some stuff. But this is a great way to reverse engineer and kind of see what's going on. And I'm going to turn the brightness down so I can actually see what's going on here. There we go. Hold on one second here. This isn't quite as smooth as that. There we go. So we can skip. There's screenshots in this presentation. And these slides are online. You can see up there, there's a GitHub URL. All these slides are online. This is the Android version of that app. It does a very similar thing. We can go out, we can connect to things, and really explore and control what's going on. So now we're going to get into how do we write applications for this stuff. So we're going to use Apache Cordova. Apache Cordova used to be known as PhoneGap. A few years ago that changed. This isn't necessarily an Apache Cordova talk, so what you need to know is that Cordova lets us use HTML and JavaScript, and it lets us write code. It gets compiled in a native wrapper, and it gets installed as a native app on your phone, but we get to write everything in JavaScript. Cordova supports a lot of APIs that provide JavaScript APIs, camera, accelerometer, those sort of things. They don't have a Bluetooth API out of the box. I wrote a plugin called the Bluetooth Low Energy plugin, and that's what we're going to be using here. So if you have a Cordova project, you can use the command line. You can install this plugin from the command line. There's a repository of Cordova plugins. You can go out and see it. So now some of the things we need to do on our app. Once you install this plugin, it's going to create a global variable called BLE that's available to your application. And then if you look at the README of this plugin, there's a lot of documentation that kind of has little snippets to show you how to do this. But we're going to walk through the important things. So typically when you start your app up, the first thing you want to do is you want to go out there and you got to scan for some devices. So you can scan for all devices or all services in the world. You could just pass in an empty array and find everything. Typically it's going to take longer, you're going to have to scan longer, and then you're going to have to filter through results. So one of the things you can do is say, I want to connect to something that has the light bulb service, and the OS will filter that for you, and you'll only get light bulbs back as you're scanning. We say the number of seconds we want to scan for, and then like everything in Cordova is asynchronous. So the last two arguments are a success callback and a failure callback. So if we look at this for the light bulb, we'll pass in the string FF10, say we want to scan for 5 seconds, and on device discovered is the method that's going to happen. Whenever it discovers a device, it's going to call this callback. So this may get called no times, it may get called 100 times. It really depends on how many devices are around. In that on device discovered, we're going to get a peripheral object. And that peripheral object is just going to be a small amount of data about this device. The thing we usually care about is the ID. That's going to be a MAC address on Android. It's going to be a UUID on iOS. We get the name of the device, and there is advertising. It is, in this case, I did it from Android, so it's actually an array buffer, so it didn't print out. You can have access to the advertising information if you want to do more extended things. If you're doing this on iOS, advertising will be another nested object that will have key values with some of the data that you can get to. So once we go through, we're going to scan, we're going to get these callbacks, and the thing we care about here is this MAC address here. Once we get this MAC address, we're going to use that to connect to the device. So the next API we'll look at is connect. Once again, we have success and a failure callback here. So we'll say connect to the device, hand it the MAC address. The onConnect is going to get called once when we connect. OnDisconnect may get called right away if there's something happens, the device went away. OnDisconnect can actually get called later. We may be using this for 10 minutes and then something happens, the device runs out of battery. OnDisconnect will then get called later. So these are long-lived callbacks. So once again, so for the success function, we'll have this onConnect. We'll get past a peripheral again. This peripheral is going to start off, it's going to look, it's just a JavaScript object. It has all that advertising information that we got before, those 4 properties, and then it has a lot more information. In our app, what we're going to do is once we connect, we can log what's in there. So we'll show you what the peripheral looks like. We'll need to read the current state of the light bulb, and then we'll need to update the UI, because once we connect, we'll have 2 buttons. We'll have an on button and an off button. We'll want to toggle that to the proper state. So this is what the peripheral object looks like. The top of it there is a lot of that same information that we had. But we get all the services the device is offering, and then I edited this because this was crazy long, and only some of the services that we cared about. You'll actually see the characteristics in there. You'll be able to get the properties. Sometimes when you're interacting with a device like this light bulb, we know what we want to do. So we don't necessarily care what comes back in this peripheral information. But if you're connecting to objects you don't necessarily know about, this allows you to interrogate them and to build dynamic UIs and really kind of figure out what's going on. So after we've connected, we'll need to read the characteristic to know the state of the light. And these UIs get a little bit verbose. We have to pass a lot of arguments into it. So this is kind of the lowest level. As you're building apps, sometimes it'll help to build another object that will have some wrappers around these reads and writes so that you don't always have to pass in the same things. So we're passing in the device ID, passing in the light bulb service and the switch characteristic. We're going to get the results of that switch on or off in the success callback. Usually it's going to return very fast, but since it's asynchronous, it might take a little bit to come back. So in the callbacks for reading, we're going to get an array buffer back. An array buffer is just a way to handle binary data within JavaScript. They're a little clunky and they'll probably make you curse a lot when you use them, but it really seems like the best way to be doing binary data at this time. So now, since I know a little bit about this service, I know that we're going to get bytes of data back. So I cast that into, or I create a typed array from that. The uint8 array is basically 8-byte array, and so we create that, and then I grab the first element out of that array, and if it's 1, that means the light's on, and if it's not 1, we're going to assume the light's off there. And so from there, we're just manipulating DOM within this callback. So then we're going to wire our buttons up. So we have a button to turn the light on and a button to turn the light off. So this starts off the same. We got the device, service, characteristics. The new thing we have here is the value. Once again, we're going to have to pass an array buffer. I construct this as a typed array. And then if you look down there, I say data.buffer. Any of the typed JavaScript arrays, you can say buffer, and it gives you the generic array buffer back, which goes really well through the JavaScript to native bridge there. So here we say we want to send a 1 so we can turn that light on. And you'll notice I'm skipping the failure callback here. I just have the success callback. Both the success and the failure callback are optional on almost everything. If you skip them, you won't always get the data you need. But if I don't necessarily care if it fails, I can just have the success callback. Similar before when we talked about write without response. The write without response API looks exactly like write. The only difference is it's named a little bit different. Some devices are very particular. If you call write without response, it won't let you write to it if it was write. Some devices will specify both write and write without response. You really got to get in and read the documentation or introspect those properties and see, hey, which way are we allowed to set this? So here's a screenshot of the Android version of the app. We'll fire up Reflector again here and see if we can get this to work. And all these code examples, I'll have a link to this one in a little bit. The code is in GitHub. Some of it is in with the plugin, and others is in separate repositories. There we go. Okay, hang on. This disconnected here. A lot of times when you have an app, you'll want to have a list of devices you can connect to. This one assumes there's only one light bulb and goes out and connects to it. And then you can see the on switch came in, and then so I can toggle it off and toggle it on. Pretty low tech, but it actually works really well. And that was done with, I don't know, maybe 100 lines of JavaScript if we actually looked at the code. So one of the things I really tried to do is try to make the API really nice to use from JavaScript and handle a lot of the tedious things that happened over and over again within the plugin. So that code is, this is an old version of slides. I think this is actually called RoboSmart on GitHub. So now if we go back to the heart rate sensor, the heart rate sensor is a little bit different. It's going to be constantly sending out data. It's going to be sending it, I don't know, maybe twice a second or something like that. Maybe not that often. And we wouldn't want to keep polling to read because that would really use a lot of our battery. So we're going to use something called start notification here. And you'll see a lot of these APIs, I tried to keep them looking very similar. So start notification, we're going to give it a device ID that we get from scanning. We're going to give it the heart rate service. We're going to give it the heart rate measurement characteristic. And then we have this callback called onData. Thing with a notification, is it's going to get called many, many times for something like a heart rate service. Failure only gets called in rare circumstances. If you're trying to start a notification on something that doesn't support notification, you'll usually get the failure call back immediately. If you don't get that immediately, it usually would continue on working. And then once again, in on data, very similar to read, we're going to get an array buffer that comes back, and we're going to need to turn this into a typed array, and we'll have to get the data out of it. And so this is one of the things on the heart rate measurement. You'd have to go and look at the specs. I linked to the specs earlier, and you'll see that the first byte has a bunch of flags. Hey, what's the units? What's is it 8-bit or 16-bit value coming back? All these things. For the heart rate that I have, I know it's going to be 8-bit, so I cheat, and I didn't do anything with the flags, and I just read that second byte to get the heart rate. And once we get that data, then we can display that value. We can either log it or put it onto the put it on the screen. So there's a heart rate service in the example in the Bluetooth Low Energy plugin, and you can see that it's very simple to run. And same thing, you go, you connect to it, and you it'll just sit there and it'll read your heart rate monitor. So if you have something like a lot of the ones you wear around your wrist for fitness and stuff, as long as it's not paired with a phone and it's advertising, you can use this code and connect to it and really check out how it works. That code, so it'll link to the code there. So here's another piece of hardware. This is Tom used this as his remote this morning. This is a TI sensor tag, and it's a pretty neat little thing. There's like 8 or 10 sensors in here. It's $25 from TI, and they really sell it just to want you to get there and use their hardware. The nice thing about it is they actually document their API, so you can figure out what the services are and how they work. And it runs off a coin cell battery. It's pretty fun little device. One of the things that's on here is there's 2 buttons on the top, and there's a button service with a key press state. And that's notification too. Whereas the heart rate is going to be notifying all the time, this button service, you could sit there for a long time not get any button presses, and all of a sudden you get a button press. So these can be very long-lived callbacks with nothing happening, and then get them to work. One side note to talk about the notifications is you need to be connected to the peripheral to get notifications. If you go out of range and you disconnect or something, you're not going to receive any of these notifications. And then if we read the documentation, we can basically just look at the first bit tells us one key, the second bit tells us the other key, and then the third bit tells us this side key. I ignore the side key in the example because by default you press the side key and the thing reboots. So we can also, it used to be called notify. There's a stop notification, so I renamed it to start notification. So this code will actually work, but it's not proper. So we can tell it, we want the button service, the button characteristic, and when the button is called, call us back. And then, once again, we get a array buffer back, we interpret that array buffer, and then we can do something like set a message on the screen and show that this is, show which buttons are pressed. If you actually run this code, there is also an accelerometer in here, and so there's another kind of notification where we have to set some characteristics to enable the accelerometer. And in this example, we read both the accelerometer data and the button data. So now in this one, I actually give it a list of sensor tags. For some reason they're showing up twice here. So this is kind of cool. So this lets the user go and pick which one they want to connect to. And then you just tap on a row. Come on, demo. There we go. And it connects. And then as we push the button on here, of course I picked the wrong one. As we push the button on here, it'll tell us which button is pressed. Potentially pressing both buttons. So this is kind of neat. You can use this. You can wire it up as a remote control to do a lot of things. Now, in this case, this is a peripheral and the phone is a central. So it's not like you can connect this to anything, but as long as you have a central device, it can reach out and connect to one of these. And that's what Tom did this morning. He had some Node.js code that was running on his laptop that reached out and connected to this. And then when you press the button, use some Apple script to send the forward key or the backward key. So you can do a lot of fun things with these little devices. All right. And once again, that code is in the examples. So that covered kind of the basics of what you can do with Bluetooth Low Energy peripherals. I think that that's one of the great areas of Bluetooth Low Energy. I do a lot of other talks where we're using Arduino and other small hardware where we actually build our own services. And there's a lot of libraries out there now that with very little code, we can build custom services, advertise those services, and then connect to them from other places. It's really, really powerful. As opposed to Bluetooth Classic, the services had to be defined by the Bluetooth Special Interest Group, and you were kind of stuck with whatever they had and whatever your device supported. Now you could do a lot with Bluetooth Classic on Android because Bluetooth Classic works well there. If you have a newer Android device with Android 4.3 or higher, you can use Bluetooth Low Energy there. On iOS, you're stuck with Bluetooth Low Energy for the most part. In order to do Bluetooth Classic on iPhone, you have to be a member of the Made for Apple program, or MFI program, and you got to jump through even more hoops than you normally do with Apple. And so I'll be able to take questions about peripherals at the end, but I want to kind of diverge a little bit and talk about beacons. And beacons are one of the areas that get a lot more press, I think, than Bluetooth Low Energy peripherals. Bluetooth Low Energy beacons come in all shapes and sizes, so here's a few of them. I put the quarter in there to give you some perspective. And if we go back to GAP or the when we're talking about Bluetooth and finding and connecting devices, the way that beacons work is they're a connectionless protocol. These devices are going to sit there and they're going to advertise out as a broadcaster, and then in this case the phone would be the observer. And it's basically just going to be reading and scanning, hey, what's out there, reading that advertising data, parsing some of the manufacturer data, and it can actually get information from a beacon without any connection. The important thing to remember here is that this flow of information is one way. It goes from the beacon to the device. So this is kind of like, the guy standing out in front of the mattress store with the big stupid sign saying, hey, something's here. I read a lot of articles, and the journalists are getting a little bit better lately, but they're like, iBeacons are going to track you, and they're going to know where you are and do all this stuff, which is kind of true, but the beacon doesn't necessarily do that. The beacon only broadcasts, hey, here's where I am, here's a number. If you have an app on your phone that's reading the beacon can then the app can figure out where you are based on the beacon, and then it can report home to a server, and they can track you that way. If you don't have the app on your phone, they're not going to be able to track you. So a lot of these things, beacons are being put to use for retail and other things like that. That's kind of boring to me, so I'm really hoping we find better, more exciting uses for beacons. So Estimote is one of the beacons there, and so this is the Estimote beacon up at top with its case on it. They got this funky little rubbery case. If you actually rip it apart, this is what's inside there. I ripped two apart so you can see each side of it. So on one side is a circuit board with a really tiny Bluetooth chip in there, and the other side is a big fat battery. These were some of the original Estimotes. On the new Estimotes, the battery is even bigger. Initially, they wanted the battery to last 2 years in these things. I think mine lasted about 2 months. The advertising rate was set really high. If you tune some of the parameters, you can bring that down and make the batteries last a little bit longer. So, like I said before, the iBeacon, so this is Apple's way of doing beacons. There's other ways of doing beacons. It's just a sign. It's a guy standing there with a sign. In this case, it happens to be yet another UUID. So the UUID is whatever you make up. If I'm deploying beacons somewhere, I can set a UUID for my beacons. I get two other pieces of data, a major number and a minor number. So if we're doing something like I was going to set up beacons at ETE, we have one location. So if I used, major could be my location, and then maybe minor would be the room, and we could say this is room A. So we'd put 10 in there, or A and hex to say we're in room A, and maybe we could have a beacon in each of the rooms. And then we could have the ETE app read and interpret that data and maybe show you some contextual information when you were in this room as opposed to when you were in that room. So we're going to talk about this from an iOS perspective because this is Apple stuff. You can actually do this from Android. There's a company called Radius Networks out of, I think, Washington, D.C. They have some Android apps that will give you a very similar API to what iOS has. You can also get in and you can just look at the raw advertising data and you can parse and manipulate the stuff yourself. But if we're doing iOS, you don't use core Bluetooth for this, which to me at first was a little bit mystifying. use core location. So from that perspective, iBeacons are more like geofencing. So there's two big concepts here. There's a region, and based on that UUID we have, we can set up a region, which is kind of like setting up a geofence around a particular latitude and longitude. And what thing we care about the region, are we inside the region or are we outside of the region? That's really kind of the two things you have with a region. And then there's something called ranging. When you're inside a region, you can do what's called range a beacon. And that's when you say, hey, how far away from this am I? And instead of saying you're 2 feet or 50 meters away from this, they break it down into smaller chunks. They say you can be immediate, like you're basically right on top of the beacon, or you can be near it, or you can be far from it. So if we're down at the other end of the room, we'd be far, probably halfway down the room we'd be far. Near it would be about meet of the light bulb, and then immediate, you're going to be like right on top of it. And so that level of granularity works pretty good, and they handle the math underneath that to figure out, hey, using the signal strength indicator and the power and that stuff. And it's usually pretty good. Sometimes it's pretty bad. So Objective-C code does not lend itself well to slides. Try to do this here. So one of the things we'll do is we'll use a location manager. So you create a location manager and you set a delegate for the callbacks to ourself in this case. We create a UUID and then we create a region using that UUID. So we say we care about this region for this beacon, and then we set some properties. We want to know when we enter it, when we exit it, and I can't remember what that third property is for. One of the other important things is we have to request authorization. This is with iOS 8. If you don't request authorization, your app is just not going to work and you're not going to get any indication for it. There's also a property you need to put in your plist. It's the message that's shown when we request authorization. If that property is not in your plist, this also won't work and you'll be like, why isn't my app working? So once you request permission, the first time you run this, it's going to ask the user, can this app use your location? And it's going to display that message that you care about. This one's requesting always authorization, which means it can be running in the background so that the callbacks that happen when we enter and exit regions will actually wake up the app, let us do something, and then go back to sleep. Once we've set all that up, we say, hey, start monitoring the region, and then we can forget about it. We don't have to worry about power consumption, or Apple tries to handle all that stuff for us. So I guess that's one of the good trade-offs for the restrictive environment, is they try to manage all that stuff and make your app a good citizen. So there's going to be two callbacks. There's going to be a callback when we enter a region, and that's the first one we care about. So when we start our app up, we're saying we created this region, we care about this region, and then we figure out are we inside the region or outside of the region. And so if we're inside the region, we're going to start ranging beacons, which means that we care about, hey, find the beacon, tell me how close I am. If we're outside of the region, we're going to stop ranging beacons. We don't want to be ranging when we're outside of the region because that will actually use more battery. This is the last one where I got to keep opening in my browser here. Sorry about that. And then so when it ranges beacons, and we can be looking for multiple regions at the same time. This example keeps it really simple. We have one region, and we assume there's one beacon. So when a beacon gets ranged, this is going to actually get called a lot. We get an array of beacons. And so to keep things simple, I'm just going to take that first beacon in the array. And then this is proximity property. And that's where we tell, hey, how close are it? And we're just going to set a label on the screen that says, you're immediate, you're near, you're far, you're unknown. Theoretically, you could have an error too, so we handle that. And so here's a screenshot. We're going to So this is a little piece of hardware from Adafruit. It's called a Bluefruit LE Friend. It is an ARM processor that does a lot of Bluetooth stuff, and then it has a serial connection on the other side, so you can use it with an AT command set. So it's kind of neat for doing things like this. You can make it be a beacon, you can make it do some services, you can make it do a lot of different things. Typically with this, you'd use another beacon instead, but this lets me have less hardware while I'm doing this. So I have a little Python script that's going to create an iBeacon there. Oh. I should connect this app before we... One of these days I'll have 2 projectors so I can do this simultaneously, but... Oh, come on. Oh, there we go. And we got some old data there. We're going to reset this app. Okay, so the app starts up and it thinks it's outside the region. Now I'm going to plug my beacon into USB. And it's inside the region and it's near. So that happens pretty seamlessly there. When it detects a beacon and then sees it, it's usually pretty quick. Sometimes some of the other changes are a little bit slower. I think it's doing some debouncing and other normalization. So for testing, that can be really frustrating. For real life, I think it's actually a good thing. So you're not going to get too many notifications and stuff too fast. So now if I move immediately on top of the beacon, we'll get immediate. A little lag here, so it's near. Then I guess if I walk over here, it says I'm far. So you can use that in your application. Now, obviously, just writing what the proximity on there isn't very useful. But you could do things like as you walked into a room, you could send an HTTP request to your home automation system to turn some lights on. You can make a Bluetooth connection to another device to do something. So there's a lot of different things you can do with beacons as long as you understand those mechanics. So you have a region. So if you're inside or outside the region, and then once you're inside of a region, you can do some ranging to know how close you are, and you can do different things based on how close you are. We were only printing the how close we were. You can also get the major and minor number while you're ranging, and you can do a lot of more smarts based on which beacon you're closer to. So that's iBeacons. The code is on GitHub, iBeacon demo. There's another kind of beacon too, and this is one that Scott Jensen at Google started. It's a URI beacon, and his idea behind this was like, let's make it easier for people to interact with physical objects easier, so we can have a beacon that broadcasts some data. And instead of broadcasting something obtuse like a UUID, let's broadcast something useful like a URL or a URI that anything can understand. So there's 2 GitHub projects about that. I encourage you to check out Physical Web first. It kind of tells you about the project. And then URI Beacon has a lot of samples for if you want to build your own URI beacons, there's different ways you could do that. So with the URI beacon, let's say same thing. We want to do something specific to this room here. So I could say, I got that URL there. It's phillyete.com/r for room and /a for room A. Now, that's pretty long. One of the things when you're advertising data, you get 31 bytes of information in your advertising packet, and some of those are taken up by other things. So I think we have like 22 for the URL. So they use a compression scheme on the URLs. This is very similar to what in NFC, if you have a URI, they compress that so you can fit on an NFC tag, and they basically do substitution. Do the same thing here. So http://www dot gets all replaced with the 00. You put that in there, we've saved a whole bunch of bytes there. We put in the bytes for each of our letters, and then once again, when we get to .com/, there's another substitution of also a 00 in that case. So there's a lookup table. There's 30 different substitutions that will help compress URLs. The problem is you may still need to use URL shorteners with this too, but this way you can get your data and get it stuffed into one of these beacons, and then the beacon can advertise that data. The cool thing about a URL is if we're advertising that URL, the server knows what time it is. So right now it could say, hey, show the session description for my session that's here. Later on this afternoon, it could show someone else's description. So if you're using something like on Android, the NRF Master Control Panel, and I was scanning, I could actually scan for that beacon, and I would see the URL right there, because this tool knows how to interpret URL beacons. Gives you a little button, you can open it. If you go to the Physical Web project, there's apps that are, I think all the source code is out there, they're open source. There's an iPhone app and an Android app. And what that'll do is it'll sit there in the background and it'll look for these beacons. It'll notify you, hey, you came in presence of the beacon, and it'll give you a notification. So then you can look and say, oh, I care about that, and you can click on it, and it'll actually open the web page. If you don't care about it, you can just ignore it and go from there. So like on my Android, when I had that beacon there, I could get a notification, and it pulls this creating Bluetooth Low Energy, I think from the title of the web page. Obviously, we didn't set our web pages up really good to get a good description there, so it just pulled some junk from the web page in there, but you get that notification. And if you're running the app, you can actually get a little bit more information. You get to see the beacons that are around you, and you can look at the description, then you can click on it, and then it will open in the web page. And so that's it. So that kind of wraps up beacons. And now those aren't the only two kinds of beacon. There's another company called Gimbal that's doing other beacons. There's a lot of other ways you can do beacon technology. So the key to beacon technology is that it's broadcast only. You have the beacon broadcasting, and you have the observer listening and reading, and then you can do connectionless data transfer, which is a really pretty interesting concept. So that wraps up my presentation. I'd like to take some time for questions if you guys have questions, and I'll answer them to the best of my ability. And also, I have Chariot stickers and business cards for if you want to talk to me later about some of this stuff. I'll be around. I brought a lot of Bluetooth hardware. If you had a problem you wanted to hack on with some Bluetooth stuff, happy to do that too.
Can you have two services running on two different devices, one being a client and one being a server, so a dual client-server relationship between two devices?
So like a phone going to a light bulb and the light bulb going to another phone?
More like two phones talking to each other.
Yes.
You can.
So on iOS, you can be, we were using iOS only in the central role where it was going out and connecting to devices. iOS you can become a peripheral also. And so it's very easy to do that, right? So one phone could offer the service and the other phone could connect to the service. With Android, it's a little bit trickier. It's not supported until Android 5, and even then, like my Nexus 5, it worked on the betas, but something with the hardware, they disabled that. So I got to get a new phone to be able to do peripherals on Android.
Okay, so expanding on that concept, can both the client service and server service be running at the same time, or is it strictly one or the other for that time?
They can be running at the same time. There will be some device-dependent issues on there. The iOS stack and hardware is pretty good. It'll let you do that. So one app can be a peripheral and another app can be a central. And I think that's one of the reasons on my Nexus 5 they disabled that, because if you became a peripheral, it broke other things that were trying to be central. So a lot of that is based on the Bluetooth spec. Bluetooth 4.1 handles that a lot better than Bluetooth 4.0. And even Bluetooth 4.2 I think is even better with the multiple connections and simultaneously doing more things.
Okay. Thank you.
Wait, hang on.
Do the beacons have various distances, or are they all pretty much that same set of distances?
The distance, so the question is, what is the distance on the beacon? The distance on the beacon is going to be really proportional to the signal strength that you're broadcasting on. So if you can crank up the power, your beacon's going to go a lot farther, your battery's going to go a lot faster. So that will be as you adjust that. I don't really know how Apple handles that, but I think that they're looking at the signal strength, so maybe we can try that later. We can crank up the beacon power and see if far gets farther out before you get to unknown on that.
Can you speak to the reliability? I know for a while when I played with it, it wasn't great a couple of years ago. Is it better now?
So on iOS, Bluetooth Low Energy is pretty stable. I can still do some things where occasionally crash the Bluetooth stack, but for the most part, it's pretty solid. Android, if you're on 4.3, you can crash the Bluetooth stack a lot. When you're on 5, it's a lot more stable, but there's still some things when I start to get weird behavior on that, rebooting my phone, or you shut wireless off and Bluetooth off and then turn them back on, it kind of reboots that stack. Things are a lot better. So it's much better than it was 6 months ago. It's still not 100%, but hey, it's software, so there's always crazy things.
What about security? You know, I don't want my friends turning off my lights or knowing my heartbeat. Is there anything built into the Bluetooth Low Energy protocol, or?
Yeah, so there is some security, but security is mostly what's called just works, where you can go out and you connect to it. So the one thing is if you have your heart rate monitor attached to your phone and they're connected, it's not going to be advertising, so it's going to be tougher for someone else to connect to that. But yeah, that service doesn't specify any security in there. If you get into which we didn't talk about, the permissions, where you say, hey, we're going to need encryption here, and where you got to go through that elevated level of security, and you'll do some pairing. To be honest, I haven't dealt with it as much as I wanted to, but it seems like part of that stuff is half-baked, and so it's really good if you want to, you're in a trusting environment, you want to make all these things work. If you're in a hostile environment, I mean, there's a lot of fun things you can do to try to hijack Bluetooth stuff and do bad things, but hopefully they'll fix that as they keep going forward.
Do you know if there's any similar Bluetooth support for like PCs and Macs? Some libraries to do the same thing as with the mobile devices?
Yes, so you can do it. You can write in Objective-C if you're on your Mac, and that works really well. I like to write a lot of things in Node.js just because I'm doing JavaScript everywhere. So there's two libraries. One's called Blino and the other's called Noble. And that lets you create, those should be the central role and the peripheral role. Sandeep Mistry, they're on his GitHub site. They're also in NPM. They're really good libraries. He's done a lot of great stuff there. That works well on Mac and on Linux. Windows is a little bit tougher. We're still kicking around trying to get some of this stuff to work. Windows 8.1 is really only where the Bluetooth is supported. So hopefully there'll be better support for that going forward, but for now you're going to be better off if you're on Mac or Linux. And then if you're on Linux, there's a lot more tools. There's Blues, and then there's Python wrappers for Blues and a bunch of other things. Some of those may work on the Mac also. I use them more on Linux.
Did I catch that right? Did you say that the security is sort of just works, so that way you can only have one client for every, or not client, but central for the peripheral, so you couldn't have multiple, i.e. your whole roommates controlling the lamp. Is that true?
Right. So with Bluetooth 4.0, if I'm connected to this light bulb, you cannot connect to that light bulb. With Bluetooth 4.1, there is provisions so that we could both be connected to the light bulb at the same time. The light bulb would have to support that in the hardware. Not too many devices support that now. The 4.1 spec has been out for a while, so I think soon we'll start seeing more hardware that does that. So one of the things you run into is if you have a home automation stuff set up, like I have this here, and that light bulb hooks into another server with Bluetooth, then I can't control it from my phone. I actually have to go into the server via HTTP and control the light bulb that way.
Yeah, I had a question. Hey, Don. So do you, thinking about testing and how you could write tests around this stuff if you started to play around with it, and if you just, if you're a test kind of person, do you see, but given that the APIs are kind of funky, the way the APIs are implemented on the device, or do you see any value in, instead of mocking all the Bluetooth stuff out, do you see any value in using like these Bluetooth emulators, like you were talking about, and having your stuff run as if it's things that's talking to a real Bluetooth device, so that way you're testing the Bluetooth stack as well, or is it just too early for that as well, or what are your thoughts on that?
Yeah, so with anything, like you'll notice, I was mirroring a device on here so I could show you how things work rather than using an emulator. So that is one of the things with interacting with hardware, you have to use a real device rather than using emulators. I do a lot of my testing with actual hardware, and it's kind of old school manual testing because I'm writing plugins and writing the stack to make this stuff work. Once I have this stuff working, if I'm writing an application that uses it, Cordova makes it really easy. I can stuff shims in there and I can mock things out. And if you're using something like Ionic, it makes it really testable, and you can kind of fake out, well, hey, yeah, some Bluetooth stuff would happen here. So I'm testing my application functionality. But as far as testing the actual underlying Bluetooth stuff, I haven't found a good way to do that other than just use real hardware. I'd be psyched if someone came up with a good way to do that, though. All right, well, I think we're about at 12:30, so I'll stick around and happy to talk to people and